In this tutorial, we're going to go over gas stoichiometry problems. So let's start with this one. What is the volume of 2.5 moles of argon gas at STP? So what exactly is STP? STP stands for standard temperature and pressure. The standard temperature is 0 degrees Celsius, which corresponds to 273 Kelvin. The standard pressure is 1 atm. Now, what you need to know is that at STP, 1 mole of gas occupies a volume of 22.4 liters. And you could prove this using the ideal gas law equation, PV is equal to nRT. So let's plug in a pressure of 1. We're going to calculate the value of V. Let's replace N with 1 mole. R is the same, 0.08206, and the temperature is 273 Kelvin. So this will give you the volume, which is 0.08206 times 273. And so you're going to get a volume of 22.4 liters. So at STP, you can use this conversion factor. 1 mole of gas occupies 22.4 liters. Now, if 1 mole of gas occupies a volume of 22.4 liters, then what volume will 2.5 moles of gas occupy? So now we could set up a conversion factor. So 1 mole of argon will occupy 22.4 liters. So the unit moles will cancel, and so it's just going to be 2.5 times 22.4. So the answer to this problem is 56 liters. So for gases, you can use this conversion factor to convert moles to liters or liters to moles. So here's another problem. Let's say if you have 175 liters of oxygen gas. What volume, actually how many moles of oxygen gas are present at STP? Try that problem. So if you have 175 liters of oxygen gas at STP, how many moles of O2 are present? So start with what you're given, 175 liters, and then just convert it. There's 22.4 liters per mole of gas. So you just got to divide by 22.4. And so 175 liters of gas corresponds to 7.81 moles of that gas. Now let's move on to our next question. Propane reacts with oxygen gas to produce carbon dioxide and water. What volume of CO2 will be produced if 8.4 liters of O2 reacts with excess propane gas? Well, first, let's write a balanced chemical reaction. So we have propane, C3H8, reacting with oxygen gas, and it's going to produce carbon dioxide plus water. Now, to balance this combustion reaction, the first thing we got to make sure is that the number of carbon atoms are the same on both sides. So I'm going to put a 3 in front of CO2. So we have 3 carbon atoms on both sides. Now we have 8 hydrogen atoms on the left, which means I need to put a 4 in front of H2O. 4 times 2 is 8. Now I have 6 oxygen atoms from the 3 CO2 molecules. 3 times 2 is 6. And I have 4 oxygen atoms in the 4 water molecules. 4 times 1 is 4. So I have a total of 10 oxygen atoms on the right side. 10 divided by 2 is 5. So I need to put a 5 in front of O2. And so now I have a balanced chemical equation. So in this problem, I need to convert 8.4 liters of O2 to liters of CO2. Propane gas is the excess reactant, so I don't have to worry about that. Now for gases, you can do a liter to liter conversion the same way as you would do a mole to mole conversion. So we have 8.4 liters of O2. Now the molar ratio between O2 and CO2 is 5:3. So for every 5 moles of O2 that reacts, 3 moles of CO2 will be produced. And since moles are proportional to liters when dealing with gases, we could say that for every 5 liters of oxygen that reacts, 3 liters of CO2 will be produced. Keep in mind, 1 mole is equal to 22.4 liters. So moles and liters are proportional for gases. That's why you can do a liter to liter conversion and get the right answer. So all we got to do in this problem is multiply 8.4 by 3 and then divide it by 5. So the answer is going to be 5.04 liters of carbon dioxide. And that's it. That's how you can do a liter to liter conversion. Number 3. 7.45 grams of solid magnesium carbonate is heated until it completely decomposes into carbon dioxide and magnesium oxide. What volume of CO2 gas will be produced at STP? Well, let's write a reaction just like before. So what is the chemical formula of magnesium carbonate? Magnesium is an alkaline earth metal with a positive 2 charge. Carbonate is CO3 2-. Because the magnitude of the charges are the same, we can simply write them in a 1-to-1 ratio. So the chemical formula of magnesium carbonate is simply MgCO3. Now, once we add heat, this is going to decompose into carbon dioxide, which is a gas, magnesium carbonate, that's a solid, and then plus magnesium oxide. Oxide has a negative 2 charge like carbonate, so magnesium and oxygen will combine in a 1-to-1 ratio. So that's the chemical equation. It's already balanced. We don't need to do anything to it. So now, how can we find the answer? We're given the mass of magnesium carbonate, and we need to calculate the volume of CO2 gas at STP. So keep in mind, at STP, 1 mole of gas occupies a volume of 22.4 liters. So all we need to do is find the moles of magnesium carbonate, convert it to the moles of CO2, and then convert that to liters. So first we need to calculate the molar mass of MgCO3. So in magnesium carbonate, we have 1 magnesium atom, a carbon atom, and 3 oxygen atoms. So the atomic mass of magnesium is 24.305. Carbon is 12.01, and oxygen is 16. So if you add it up, you should get a molar mass of 84.315. Let me make sure this is correct. Yeah. So that's it. And the units for this is grams per mole. So now what are we going to do with this information? So now we can start with what we're given, 7.45 grams of MgCO3. Now using a molar mass, we're going to convert it to moles. So 1 mole of magnesium carbonate has a mass of 84.315 grams. So now we can cancel the unit grams of magnesium carbonate. Now we got to change the substance from this substance to that substance. And the molar ratio is 1-to-1. So for every mole of MgCO3 that reacts, 1 mole of CO2 will be produced. Now that we have moles of carbon dioxide, we can now calculate the volume using the molar volume. That is, 1 mole of gas, CO2 is a gas, occupies a volume of 22.4 liters. And so now we can get the answer. So it's going to be 7.45 divided by 84.315, and then multiplied by 22.4. So you should get 1.98 liters of carbon dioxide gas. This is the answer. Number 4. Solid magnesium nitride reacts with excess liquid water to produce ammonia gas and solid magnesium hydroxide. If 4.7 liters of ammonia gas was collected at 300 Kelvin at a pressure of 1.6 atm, how many grams of magnesium nitride was consumed in the reaction? Well, let's begin by writing a balanced chemical equation. So what is the chemical formula of magnesium nitride? Magnesium, as was mentioned before, has a positive 2 charge. Nitrogen has a negative 3 charge. So to combine them, it's going to be Mg3N2. And it's in the solid state. Now it's going to react with liquid water, which is just H2O, and it's going to produce ammonia. Ammonia is NH3, and it's in the gaseous state. And we're going to get magnesium hydroxide as a product. Hydroxide is OH minus. So to combine these two, we're going to get Mg1OH2, which we can simply write it as MgOH2. Now let's balance the chemical equation. So how can we do it? Notice that we have 2 nitrogen atoms on the left side. So we got to put a 2 in front of N. Now we have 3 magnesium atoms on the left, which would imply that we need a 3 in front of MgOH2. So now notice that we have 6 oxygen atoms. So that implies we need a 6 in front of H2O. And we have a total of 12 hydrogen atoms now. 6 times 2 is 12 on the left, 2 times 3 is 6, and 3 times 2 is 6. So that works out. So everything is balanced at this point. Now, let's move on to solving this problem. We're told that water is the excess reagent, which means that magnesium nitride is the limiting reagent. So the amount of ammonia that's produced is directly tied to magnesium nitride. Now we're given the information for ammonia. We got the volume, the temperature, and the pressure, which means we can calculate the moles of NH3 produced. And by knowing that, we could find out how many moles of this thing reacted, which can help us to determine the grams of magnesium nitride that was consumed in the reaction. So first, let's use the ideal gas law, PV equals nRT, this equation, to calculate the moles of NH3 that was produced in the reaction. If we could find that, then we could use that to calculate the grams of magnesium nitride consumed. So the pressure is 1.6 atm. The volume of ammonia is 4.7 liters. Our goal is to calculate N. R is a constant, and the temperature is 300 Kelvin. So first, let's multiply 1.6 by 4.7. So that's 7.52. And then let's multiply 0.08206 times 300. So that's 24.618 times N. So to calculate N, we got to divide 7.52 by 24.618. So that's going to be 0.3055 moles of NH3. So now we need to convert moles of NH3 to grams of Mg3N2. So let's start with this value that we now have. So first, we need to use the molar ratio to change the substance from NH3 to Mg3N2. And we have a 1:2 ratio. So for every 2 moles of NH3 that are produced in a reaction, 1 mole of magnesium nitride will be used up. So now we can convert it to the grams of Mg3N2. So let's find the molar mass. We have 3 magnesium atoms and 2 nitrogen atoms. So that's going to be 3 times 24.305 plus 2 times 14.01. And so that's about 100.935. So 1 mole of magnesium nitride has a mass of 100.935 grams. So it's going to be 0.3055 divided by 2 times 100.935. And so the final answer is 15.42 grams of magnesium nitride. So that's how many grams of that reactant that was consumed in this reaction in order to produce 4.7 liters of ammonia under these conditions. Number 5. 4.85 liters of ammonia gas at 27 degrees Celsius at 1.5 atm was mixed with 5.23 liters of oxygen gas at 32 degrees Celsius at 1.63 atm to produce water and N2. Determine the volume of N2 produced if it was isolated and collected at 37 Celsius at a pressure of 1.52 atm. So how can we do this problem? Well, let's start with a balanced chemical reaction. So we have ammonia reacting with oxygen gas, and it's going to produce water plus nitrogen gas. So how can we balance this chemical equation? Well, we have 2 nitrogen atoms on the right side, so that may imply that we should put a 2 in front of NH3, which now means we have 6 hydrogen atoms on the left. So we should put a 3 in front of H2O. And so now we have 3 oxygens. To get 3 on the left, 3 divided by 2 is 3/2. And so this is going to give us a fraction. Whenever you get a fraction like this, multiply everything by whatever number you see in the denominator, which is 2. So we're going to multiply everything by 2. So let's put a 4 in front of NH3. So now we need a 2 in front of N2. And 4 times 3 is 12. So we need a 6 in front of H2O. And now that we have 6 oxygen atoms, we need a 3 in front of O2 to have 6 on the left. And now the reaction is balanced. Now, what should we do next? How can we calculate the volume of N2 produced? Whenever you wish to calculate the theoretical yield, or the amount of product that's produced, you need to identify the limiting reactant. And in this problem, we don't know which one is the limiting reactant as of yet. We have information for NH3 and O2. So in order to find the limiting reactant, we need to calculate the moles of every substance first and see which substance has the lowest mole per coefficient ratio. So I'm going to use PV equals nRT to calculate the moles. So to solve for n, divide both sides by RT. So PV divided by RT is equal to n. So the moles of NH3 is going to be the pressure, which is 1.45 atm, times the volume of 4.85 divided by R, which is 0.08206, and then we have a temperature of 27 degrees Celsius. So we need to convert that to Kelvin by adding 273 to 27, which is 300 Kelvin. So 1.45 times 4.85, and if you take that result divided by 0.08206, and then divide that result by 300, the moles of NH3 that you should get is 0.2857. Now let's do the same thing with O2. So the pressure is 1.63. The volume is 5.23. And then we have R. And then multiply by the temperature, which is 32. 32 plus 273, that's 305 Kelvin. And so the moles of O2 is 0.3406. So now, which one is going to be the limiting reactant? Is it O2 or NH3? To find out for sure, divide the moles by the coefficient, which we could see here, and see which number is lower. 0.2857 divided by 4 will give us a mole per coefficient ratio of 0.0714. And in the case of O2, 0.3406 divided by 3 is 0.1135. So NH3 has the lowest mole per coefficient ratio, which means it's the limiting reactant. It's going to run out first. O2 is the excess reactant. So at this point, we don't need to worry about this number. We're going to use the moles of NH3 to calculate the volume of N2 produced. So first, let's calculate how many moles of N2 that will be produced. So we're going to start with 0.2857 moles of NH3. And the molar ratio is 4 to 2. So if 4 moles of NH3 reacts, 2 moles of N2 will be produced. So 0.2857 times 2 divided by 4, that's about 0.1429 moles if you round it. So now that we have the moles of N2, we can use that to calculate the volume of N2. So using the formula PV equals nRT. So the pressure of N2, we have it as 1.52 times V, which is what we're looking for, equals N, which is the moles is 0.1429, times R, 0.08206, and N2 is collected at a temperature of 37. So we got to convert that to Kelvin by adding 273. So 37 plus 273 is 310 Kelvin. So let's multiply the three numbers on the right. 0.1429 times 0.08206 times 310. That's 3.6352. So the volume is going to be that number divided by 1.52, which is 2.392 liters. So this is the volume of nitrogen gas produced in this chemical reaction. So whenever you're given the information for both reactants, and if you need to calculate something regarding the products of one of those reactants, then always identify the limiting reactant, the one that runs out first. Number 6, 24 grams of zinc was mixed with 245 milliliters of a 1.75 molar HCl solution to produce hydrogen gas and aqueous zinc chloride. Determine the pressure of H2 isolated and collected inside a 500 milliliter test tube at 25 degrees Celsius. As always, let's begin with a chemical reaction. So zinc reacts with hydrochloric acid to produce hydrogen gas and zinc chloride, which is ZnCl2. Now we need to balance the reaction. So we have 2 chlorine atoms on the right side. So we need a 2 in front of HCl. And so we need a 1, a 1, and a 1 here. By the way, for those of you who are wondering how to come up with this formula, you need to know that zinc has a +2 charge and chloride has a -1 charge. So to balance the charges, you need to combine it in a 1:2 ratio. Now, in this problem, we're given the information of both reactants, zinc and HCl. So just like the last problem, we need to identify which one is going to be the limiting reactant. Is it going to be zinc or HCl? So let's calculate the moles of each reactant first. So let's start with zinc. We have 24 grams of zinc. And the molar mass of zinc is about 65.39 grams. So 24 divided by 65.39, that's 0.367 moles. So I'm going to put that here. Now let's do the same thing for HCl. So we have the concentration of HCl. Molarity is moles per liter. So a 1.75 molar solution means that we have 1.75 moles of HCl per 1 liter of solution. Now to get moles, we need to multiply it by the liters of the solution. So we need to convert 245 milliliters into liters. To do that, divide it by 1,000. So 245 divided by 1,000 is 0.245 liters. Now what's our next step? Now notice that we really don't need another step. Once we cancel the liters, we're going to have moles of HCl. So it's just 1.75 times 0.245. And so that's 0.4288 moles. Now we need to compare the mole per coefficient ratio. If we divide this by the coefficient of zinc, which is 1, it's not going to change. If we divide this by 2, that's going to be 0.2144, which is less than 0.367. So therefore, HCl is the limiting reactant, zinc is the excess reactant. So we should base our answer on the moles of HCl. Our goal is to determine the pressure of H2. And we have the volume and the temperature. All we need is the moles of H2, which we can use this to convert it. So let's start with 0.4288 moles of HCl. The molar ratio is 2 to 1. 2 moles of HCl is equivalent to 1 mole of H2 based on this reaction. And so we just got to divide 0.4288 by 2, which is 0.2144. So now that we have the moles of hydrogen gas, we can now calculate the pressure using this formula. PV is equal to nRT. So the volume is 500 milliliters. But if you're going to use an R value of 0.08206, V has to be in liters. So if you divide 500 by 1,000, you're going to get 0.5 liters. And we have N, it's this number. And we know what R is, 0.08206. And the temperature, we need to convert it to Kelvin. 25 plus 273 is 298 Kelvin. So it's going to be 0.2144 times 0.08206 times 298, and then divide that by 0.5. So the pressure is 10.49 atm. And so this is the final answer.